Hello everyone, for first updates now, I'm Tyler Olds and you're watching Behind the Bumpers. This fun show where we dive deeper in the robots, what makes them work, and talk a little bit more about the team. And today I'm here with team number 5114 Titanium Tigers, coming in from Fenton, Michigan. 5114 started back in 2014, where they won a trifecta of the Rookie All-Star, Rookie Inspiration, and Highest Rookie Seed, and has gone on to win a plethora of awards, including a District Chairman's Award, 2 district event wins, and were finalists in Michigan State Championship in 2017. 5114 also had an opportunity to compete last season at the Michigan MCC event, where they were semi-finalists. And today I'm here with Sean, Tom, Adam, and Sean, and we're going to be diving deeper into this modified 2020 robot, talking about some of the changes that they've made, successes they've had, iterations, all this and more coming up on Behind the Bumpers.
Giving you a voice,
making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Sean, you're going to be breaking down some of the subsystems of the power cell, starting out with the intake. So tell us a little bit more about it, and I'd love to hear any changes and iterations your team has made throughout the 2020 and 2021 season.
All right, so as you can see when looking at our intake, we have an intake that spans the entire front bumper of our robot, and we use vectoring wheels to center a ball, which allows us to pick a ball up anywhere from our front bumper, and it will automatically center itself when moving into our intake. One iteration that we did have to make to this is this X cover in the center of our intake. We did this because while testing our robot before our season, we realized that power cells were being sucked up and getting caught in between a few of those rollers that we created. This X plate stops this from happening and allows the ball to move straight from the intake into our elevator without any pauses or issues.
And what material is that made out of?
The cover is made out of carbon fiber, and the rest of the intake is primarily made up of aluminum, and the spacers on this bar are made up of plastic.
So one of the things to ask with the intake that you have that we've seen with teams is obviously the wide intake works really well. The vectored intake wheels work great. You have a pretty narrow funnel as it comes in right away. Has that cross that you created, has that helped out with in regards to getting power cells in your robot? Was that causing some of the jamming issues, or can you elaborate a little bit more on that?
The jamming issue was mainly caused along the front bumper where the ball enters the robot. And you can see that we have 2 rollers that come into contact with the ball right when it rolls up into our actual robot. And the problem was when it was being lifted up to get over our lip, it was getting sucked in between those 2 rollers. This plate that we put on top prevents them from being sucked out of the robot and forces them into our intake, which will lead into our elevator.
Yeah, that makes a lot of sense. Well, let's continue on and talking about the process of the power cell going into your robot. So what's up next?
Next, the power cell will enter our elevator, which is made up of grippy wheels, which keep it centered, along with this orange poly belt that you can see. We designed this poly belt in a way that it auto-centers the ball for the entire elevator system, and ensures that when it reaches the shooter, it will always be centered exactly, so we don't have any variation in where our ball is shot. The entire system is driven off of 2 motors, and we have 2 sections in our elevator. We have a lower section and an upper section. We designed it this way so that way we can sequence our balls properly to get the optimal shooting speed and time that we want for balls to be exiting our robot.
So I really like that idea of the 2-stage there, right? Because you're not always going to be able to intake all the power cells consecutively one after the other. So it definitely provides you a lot of opportunities with that as well too. So yeah, I mean, not much to see with that. It looks like it's very efficient that way. So let's head into the shooter on your robot.
All right, so moving on from those systems, our shooter is made up of two two main parts. The first of which is our hood, and we did a couple modifications this year to the hood. We had to adjust our hood by creating an adjustable flap using a pancake cylinder. We did this because when we were competing last year, we always shot from the exact same location. But because of the new game this year, we have to have a variable hood allowing us to make shots from all the different spots on the field. Our shooter is made up of a flywheel that runs off of two brushless Neos. And we did this, we put dampening wheels on the side, which are made of aluminum. We did this so that way our shooter does not lose any speed while shooting multiple balls. So we can consecutively shoot as many balls as possible in as quick time as possible.
Talk to me about the flywheel a little bit. How heavy is the flywheel that you have on there? And then was that your initial iteration that you had?
It is our initial iteration that we had. We did have to make several adjustments to the way the system was mounted, but those were pretty basic changes overall. And we designed it to be extremely lightweight. We accomplished this by using aluminum, which is a light material, in both the flywheels and the shaft that it's held onto. And we used 4 wheels to accommodate the entire accommodate the ball anywhere it may be in the shooter, even though we do have a self-centering elevator.
And one last follow-up on that. You mentioned with the adjustable hood, does that change how your compression ratios work at all with the power cell? Because if you start adjusting that hood, that obviously there's more contact or potentially for a longer time with the power cell. Did you have to make any adjustments to either your RPM or to how much compression you have on the power cells?
We did have to adjust the RPM, but not the pressure. That remains the same regardless of which orientation the flap is in. The only difference is the speed that we have the Neos running at when shooting.
Well, appreciate hearing about these systems for the power cell. We're going to be moving on to Tom. And one of the things that, of course, in 2021, there isn't a climbing aspect, but we do love to still highlight teams who have built climbers because the 2020 season required that, and we're still highlighting robots that way. So, Tom, talk to us a little bit more about your climber and what you're doing for that on your robot.
Yeah, so last year we were able to demonstrate this really well, but this is powered pneumatically. So when we want to deploy it, it will shoot straight up, and within less than half a second probably, you're able to walk up to the bar and begin pulling this back down so it lifts it up. But that's really unique because we're able to deploy and get to the bar very soon compared to other teams. Many of them maybe take a second or two to lift their elevator up, where ours is almost instant. And we have 2 springs in here, which pull it, keep it in place, and pull it back down once it's activated.
So, have you, in your journeys of climbing, have you had times where only one hook gets wrapped on, and have you been able to climb with just one?
That might have happened once, but we're usually able to center it. We have a crawling mode for when we want to do that, so we're able to go really slow and align very well.
Yeah, no, that makes a lot of sense. So next up, we're going to be going more into the electrical on this robot. I know there's been, of course, with the hooded shooter, I'd love to hear about some of the changes in that, and any other sensors that are being used as well, too. So Adam's going to be covering some of that on your robot. Let's hear about it, Adam.
All right, so our robot, we have 13 motors, which is a lot of motors, we'd like to say. And with those, as Sean said, we have the 2 motors that are driving each stage of the elevator. We also have another motor powering the entire intake. Both those are on versaplanetary gearboxes with 10-to-1 ratios. And then, as Sean said, we have 2 Neos powering our shooter flywheel. And then along with those, we have these custom 2-speed gearboxes, which are both powered with 3 Neos each, giving us the speed and the accuracy that Tom was talking about during climbing phase. And also this shooter, or this adjustable hood that we had to add this year, as Sean said, we added a pancake cylinder to allow us to adjust this adjustable hood. And instead of running all new pneumatic lines, we just took the existing pneumatic lines that actuated the hooks, and we just added extensions to account for our new pneumatic pancake for the adjustable hood. And then the sensors on the robot also at the beginning of our elevator, there is a photo optic reflective sensor that helps us count the amount of balls that enter the intake, so we do not go over the 5 max limit last year, and to help during auton make sure that we grabbed all the balls that we needed during our auton runs.
So if you actually got 5 in, it would actually not allow the operator to intake any more power cells?
Yes, that's correct.
And then when you shoot them out, is it reset that counter, or how does that work?
Yeah. Once you hit the button to shoot, it will reset the counter so you can go grab 5 more balls.
So, Adam, we're going to take our poll that we do a lot on Behind the Bumpers here for our electrical team, especially when specific electrical students are talking about it. Where does electrical fit in the hierarchy of the robot here? Is it one of those where mechanical gets to do everything and they say, here, make it work and package it around what it needs to be? Or do you get to have some say in kind of how the packaging of electrical is going to be prior to the robot being completed?
Well, we've been using this gearbox for a couple of years now, so and it's kind of co-op effort. I wouldn't say they give it to me when they're done with their part. They kind of give me room. We kind of talk about how much room I need, and then they kind of try to help me fit it into the robot, working around their systems.
Hey, I'll give kudos to your team for doing that. A lot of teams don't even have that conversation. So, yeah. No, that's awesome, man, and great to hear on that. So next, we're going to be going back and talking a little bit about the gearboxes that you have on that. So Sean's going to be coming back on and covering that, and then we're going to be heading over to the other Sean to talk about some of the programming on your robot as well.
All right, so to drive our entire robot, we use two speed gearboxes. To run these gearboxes, we use 3 brushless motors. And for shifting, we use a pneumatic dog shifter. And the beauty of this system is it is extremely lightweight for what it does and extremely modular. We accomplished both of these things by when we designed it, we designed it so that way we could use different gear ratios for different games, although we have maintained the same gear ratios for both the games we used it in. And these ratios allow us to go across the field in high gear at a pace of 16 feet per second and in low gear at a pace of 6 feet per second, allowing us to fly across the field while also having immense control over our robot. As you can see, it's an open air design, which helps keep the entire system light. And all the frame supporting this is made out of 6061 aluminum, which is extremely robust but lightweight at the same time. When we don't want it to be an open air system, we do have these 3D printed PLA plus covers that we can put on it, which are also extremely light to help cut down on the weight of the robot as a whole.
That's really cool. One thing I'm curious, I always like to ask teams is what made you determine your different speeds that you're going to? Is that something that is driver input that it's like, hey, I want to go at these speeds, or at what part of the process is like, hey, we want to go at these 2 speeds specifically, and what's your cost benefit analysis to those?
Well, we used the JVN calculator while determining our gear ratios, and we decided on these gear ratios after testing. We used iterative testing because we built a practice robot that we put these gearbox on, and we drove it around at different gear ratios to determine what the best one would be for a driver to be able to control it while still in high speed. So the benefit of these gear ratios, which we've determined, is extreme control when in low gear, especially for last year's game with the alignment of our hooks, but also being able to fly across the field to pick up power cells when in high gear.
Yeah, fair enough. Glad to hear another team's using the JVN calculator. Obviously a great resource for teams out there. So we're going to be wrapping up with programmer Sean, who's going to be talking about some of the different aspects of programming. I know a couple things you want to mention in regards to the Limelight you're using on your robot. So Sean, tell us a little bit more.
Yes, thank you. Our Limelight has been very useful for us last year and this year, especially with our little auto aim system, where if you the driver holds a certain button on the controller, the Limelight tries to see what angle it's at to the target. Our current target is set up over there. You see, if we're a little bit off to the right, the whole robot will actually slightly move to the left, and then vice versa, so that there isn't just a spray and pray, hope we try to hit it. There's actually some kind of guidance and aiming system. now, you see, another special thing we have down here at the intake. See, the way that the system worked of the maximum of 5 or the maximum of 3 that we have now is if you can see this little red dot here, there's a reticle down here that keeps it down. If a ball covers it, the intake's not on now, but if a ball covers it, the intake goes up. That way you don't have to manually turn on the conveyor belt to suck up a ball. It just brings it in automatically. It keeps it from getting congested, as I'm sure everyone that's was here for last year and this year knows. These yellow balls do not like being congested, considering how sticky and squishy they are.
No, I really like hearing about the thought process that went into that. It's, I think, you know, for somebody who's been behind the glass before, obviously a big benefit to have something like that, where the less you have to have your drive team, you know, trying to be more cognizant and thinking about that stuff, the better off you're going to be. So really appreciate that, Sean. So 5414, thank you so much for taking the time to speak to us about your robots and the upgrades you've been making and how you've been tackling the 2021 season. So we wish you best of luck with any of your submissions, and then can't wait to see what you come up in the future years. Thanks for taking the time. We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.